Okay, so today we are going to look at lesson 5, which talks about exponents. So if you're looking at your paper, you'll see that we have a problem written with exponential notation. Exponential notation just means that you're going to see a number and an exponent. So in exponential notation, there are two parts. We've got a large number or big number, and the big number is called the base. And then we have a small number, which is our exponent. Okay, exponential notation is just another way to write a repeated multiplication problem. So in the repeated multiplication problem, the base is the number being multiplied. And the exponent is the number of times it's multiplied. Okay, so there are specific ways that we read exponential notation. You always read it as the base to the exponent's power. So for example, this one would look as 6 to the third power. However, there are some special exponents that we'll talk a little bit more about in a few seconds. And 3 is actually one of those special exponents. This one is read a little differently. We read this as 6 cubed. This is important. You're going to see this a lot, and you need to know what it means, especially on quizzes and tests and homework. Cubed is an exponent of 3. And the reason for that is if you think about a cube is a three-dimensional figure. It has a length, a width, and a height. So that would be 3 numbers multiplied together, which is exactly what you'll be doing whenever you have an exponent of 3. So 6 cubed really means 3 6s multiplied. The exponent tells us how many times to multiply the base. So I start by writing down the base, looking at the exponent and seeing how many times I'm going to write it, and then I just put multiplication symbols in between those numbers. Now, if we wanted to evaluate this, we would need to make sure that we are multiplying, not adding. So we would do 6 times 6, which is 36. I always break it down too. And then we're going to multiply the 36 by 6, which gives us 216. So as I said before, there are some special exponents. One of them is an exponent of 2. And just like an exponent of 3, this is read differently. So an exponent of 2, and in this case we're using our base of 5, this would be read as 5 squared. Just like with the cubed, a square has 2 dimensions, length and width. So we're multiplying 2 numbers here, so that's exactly what you do when you have an exponent of 2. So 5 with an exponent of 2, 5 squared. As we already said, an exponent of 3 is read as whichever base number it is, in this case 5 cubed. And now the other 2 exponents don't really have to do with how they're read, but more as what they're equal to. So 5 to the first power, anytime you have an exponent of 1, it's just the number itself. 1 5 is just 5. Anytime you have an exponent of 0, which is our last special exponent, that's always equal to 1. There is an explanation for this, which if you'd love to look it up on the internet, please feel free to. We're not going to go into it right now, but just know that anything to the 0 power is 1. Okay, let's look at the next piece. So there's some examples. It's asking us to write each repeated multiplication problem using exponential notation. Remember, exponential notation just means written with an exponent. Then evaluate the expression, if possible, and we'll see what that means on the last example. So in the first one, if you're seeing repeated multiplication, the first thing that I would do is write down the number that's being multiplied as my base. So we have repeatedly multiplied with 5, so I'm going to write down a large or a big 5 as my base. Then I'm going to count how many times it's being multiplied. 1, 2, 3, 4. So 4 would be my exponent. So this is 5 to the 4th power. If I'm going to evaluate it, that means I would want to go back to that repeated multiplication, and I'm going to break it down. The way I'm going to break it down is I'm going to see that 5 times 5 is 25, and 5 times 5 is also 25. So I would be multiplying 25 times 25. I'm going to take out my calculator, and I am going to multiply 25 times 25 and see that my answer is 625. So when evaluated, that's 625. Okay, so for the next one, I can see that 2 is being repeatedly multiplied. So my base is 2. I'm going to count how many times. 1, 2, 3, 4, 5, 6. So this would be 2 to the 6th power. Again, I'm going to use my repeated multiplication to evaluate that. And I really want to caution you on 2s because this is the one where kids tend to add them together instead of actually multiply them together. So please make sure that you are multiplying. So 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4. So I keep breaking it down. 4 times 4 is 16, and 16 times 4 is 64. So evaluated, that would be 64. Now the last one, notice it's using a variable. So the variable being repeatedly multiplied is y, so y is my base, and it's being repeatedly multiplied 1, 2, 3, 4, 5 times. So it's y to the 5th power. Now with this one, I'm not told what y is equal to, so this is one where I cannot evaluate it. I would just leave it as y to the 5th power. Notice in the directions it said if possible, so this is one that's not possible to evaluate. Okay, so now the next ones want us to write each exponential notation as a problem using repeated multiplication. Then evaluate the expression, again, if possible. So in number 4, it says 4 to the 5th power. Remember 4, or the base, is the number that's being repeatedly multiplied. So I'm going to start by writing down 4. Then I see that the exponent is 5, so I am going to write 5 fours down, and I'm going to put multiplication symbols in between. Now once again, I'm going to break it down to multiply it. 4 times 4 is 16, 4 times 4 is 16, and then I have times 4. Okay, so next I would maybe even do the 16 times 4, which is 64, and multiply that by 16. Again, I am going to come over and take out my calculator to do the math. I'm multiplying 16 times 64, which gives me 1,024. Okay, so the next one is 7 to the 3rd power, which remember we read as 7 cubed. The base is 7, so I'm going to write down 3 7s, which I'm going to multiply together. 7 times 7 is 49, and I have to multiply that 49 times 7, which gives me 343. Okay, the last one involves a variable. So the base is h, meaning I'm going to start by writing down h. I'm going to write it down 4 times, and I'm going to put multiplication symbols in between each. Remember to make sure you're using the dot for multiplication when you're using variables. This one we can't evaluate because we don't know what h is, so we would just leave it at h times h times h times h. Okay, so the next one really brings us back to the lesson from Monday as well as today's lesson. So it's asking, what is the difference between 3g and g cubed? So if I write these two out, going back to what we just learned, I'm going to start with the second one. We saw that our base here is g, so I'm going to write that 3 times. So g times g times g. So when we have an exponent, it's repeated multiplication. And if you recall from Monday, 3g means 3 g's added together. So the difference here is when we're using an exponent, it's repeated multiplication. And when we put a coefficient in front of our variable, we're multiplying a number in the variable together. That's actually representing repeated addition. Okay, so you have to remember that. That's always a question on quizzes and tests. So make sure that you understand the difference between 3g and g cubed, or any other number similar to that. Okay, so those are the examples for today. What you can do now is go into Play Pause It and work on the exercises with your partner. Good luck.